No, okay, it's not necessary. Okay, you can see that. So we have many topics what we know, and we can add many other topics, a lot of different knowledge about transport. But more important question is, what doesn't we know? And for example, what is the real environmental impact of transport systems? Do we know that? I'm not sure. Because we can say about, for example, CO pollution. We can say something about other pollution as well. As we have some pollution detectors somewhere in our cities. But is it the knowledge about transport systems? Not exactly. Because pollution detector collects data from everything. And at the moment, in this point, we don't know which part of this pollution is from the transport system and which part of this pollution is from the others. And the next question, very important, what are the routes and travel patterns of the vehicles? I know that in many countries, in many cities, where they have very efficient traffic management systems, they are able to collect data. But let me give the example from Italy. One time I was in Torino in traffic management office, let's say. I saw that they have a lot of fantastic detectors. They use the data to establish the parameters of traffic lights, city traffic lights. And I asked them, do you collect this data? Do you analyze this data in the context of number of passenger cars, number of trucks, number of vans? Do you analyze this data in the context of the travels through the city? They said, no. They were a little bit surprised that I asked about it. This is very important topic. Without that, we don't know what is the dispersion of the pollution of the city area. We know this slide is a very good presentation, very good figure of the most important problem related to CO2. We know what is the part of CO2 emission approximately from transport systems. We know that mostly in the middle, these emissions are from cars, not from air transport, not from rail, not for shipping transport, not from vessels, but from cars, from motor transport. And we know that very big part of these pollutions are from private passengers transport. This is very important topic because sometimes we can find a lot of opinion that we have to significantly reduce the flights, for example. But I'm not sure if this is the most important problem. Much more important problem is to reduce the number of travels of passengers. But other important question, or maybe important issue, theoretically, we can remove from the city center private passenger cars, private passenger movements. Because we can say that in pure city center, we haven't got flats, we haven't got apartments, we have only hotels, restaurants, we have shops, we have production plants, and there are not any people who live there. People live outside the city center. And theoretically, we can say, okay, good. In this situation, we close the city center to the private passenger cars. As I said, theoretically, we can do that. But we can't remove from the city centers freight transport. That's completely impossible. We always need freight transport in the center of the city. And okay, what is next in this discussion? Usually, do you know why I mark the carbon dioxide using the other different color. Do you know why?
So this is for electric vehicles. It's a greenhouse.
This is greenhouse gas. This is global pollution.
This
is not dangerous for us. This is dangerous for our planet. But when we are talking about pollution, especially about pollution in the cities, all the time, or mostly, we are talking about CO2. We said CO2 is not so good, we have to reduce CO2. I don't want to say that this is not important. This is very important. But when we are talking about transport in the cities, we have to much more focus on this kind of pollutions. Why? Because these pollutions are dangerous for us. These pollutions are local pollutions. These pollutions involve on our health. That's the problem. These pollutions are in our body. And when we look at electric vehicles, we can say that reduction of CO2 in this case is not so big because it's very strongly related to energy production system. For example, in Poland, implementation of electric vehicles, it's not so efficient in the context of reduction of CO2 because we have not good for that energy production system. But when we look at local pollution, electric vehicles are very interesting option because they significantly reduce this kind of pollutions. Okay, and one more very important thing. Usually when I talk about environmental impact of transport systems, I didn't do that on slides, sorry, forgot about that. But I want to say that there are no zero emission transport. We can see in many documents, in many European Union programs, in many cities, we can see zero emission bus. We have zero emission program. We will be zero emission. No, that's not true. No option. Transport systems will always produce some emissions. That's clear. Okay. The question is how to measure transport environmental impact. And I would like to show you two examples. Both examples are from our research project realized at our faculty. This project was realized in cooperation with Norway in TOI. This is Transport Economics Institute from Oslo. And the other partner was Vitronic Polska. Vitronic Polska is a part of Vitronic company. This is German company. Very, very big, very interesting company from Dortmund, probably, I'm not sure, probably. And one of the most important elements of our GrassNext project was to prepare the system which will help us to analyze what are the pollution from the transport system. What is the problem? When we look at the street, we can say that this kind of pollution, this is the pollution in a point, in a chosen point. And to analyze point by point on the road, we should use a lot of detectors, a lot of devices, and that's impossible. It's impossible to buy 100,000 detectors and put them in many places on the road. So what we did? We decided to use traffic detection systems and pollution modeling. And based on this, we prepared web application. This application is available. I will show you the link. We use for the analysis topo traffic detector. This detector was delivered by Vitronic company. This is very interesting because it's portable detector. We can take this box and put on the on the street from the road sign or somewhere else. It's very easy, and we put it about 1.5 meters above the ground. And to prepare this device for work, we need for that about, I don't know, 5 minutes. That's all. And this detector is able to analyze 2 lines at the same time. It's able it includes 8 or even 9 categories of the vehicles. Very important thing, this detector is equipped with a GPS localization system and real-time communication to send the data in real-time mode. And we use these detectors in few parts of Szczecin, but not only. We prepared the models of the pollution dispersion. Sorry, don't ask me about this model. This model was prepared by my colleagues from environmental department. I think that maybe it's a little complicated, but the colleagues told me that it worked. I believe them. And we use this model for online application. Here is the link to the application. We have the menu on the left. In this menu, we are able to add the name of the country. Sorry, at the moment we have data only from Poland. Matt knows we are ready, and Kitronik will be very happy if you tell him that other countries are interested in it. But first, you have to have topo detectors. That's the problem. And we can choose the voivodeship, the region. We can choose the city, and here we can choose the topo detector. We are able to choose data, the time period. Also, we can choose the vehicle categories. In this system, we use only four or five categories, but it's absolutely enough for this purpose. And we can, what we can do here, sorry. We can, here we can choose the type of pollution. At the moment in this app, we have 3, NOx, CO, and PM probably, but I'm not sure. And here we can choose the weather conditions. And after that, we have to click on this button, and we get this graphical presentation of the dispersion. In this analysis, we use the weather conditions, like, for example, wind, direction of the wind, power of the wind. When you put the cursor on the line, you can see the numbers. What is the emission? And what is interesting in this application? Based on this, we can analyze different points on the road, and we can analyze how the emission from the vehicles in this point will influence on the other parts of the road, on the other parts of the city. Also, we can decide what is the area of the analysis. You can see that on the screen, but usually it's not necessary to analyze very big area. So this is the first example. Of course, I know that this is not the best option. Of course, we can find a lot of weaknesses of this system, but this is, in my opinion, good step, first step, maybe second step, because it is based on our previous work. This is second step to get more realistic data in the context of pollution. And when we go to the risk analysis, we use the concept of drone grid. We use drone DJI Phantom 4 Pro. And the concept of drones, drones grid, is the concept of using at the same time the system of drones and algorithms are able to identify chosen vehicle as the same which was identified by the previous drone. You know, so it means that when that drone will identify the vehicle, the second drone will know that this vehicle, this is exactly the same like in the eye of the first one. You know what I mean? Mm-hmm. And based on this, we are able to use this drone on few road junctions. And based on this, we are able to show what is the route of the vehicles. And we use these drones on few road junctions. The most important problem was the identification of the vehicles. And my colleagues prepared very efficient algorithms which were able to analyze different elements of the picture to identify that this element of the picture, this is the vehicle, what kind of vehicle, and this vehicle on the picture from drone 1 is the same like the vehicle and the picture of drone 2. There is the picture of three localizations of our system. This is general algorithm of the analysis. And here you can see next stages of the pictures analysis, pictures recognition. We use this system, for example, for the analysis of the line occupation during the, for example, deliveries. What will happen if the driver will stop on the line? And you can see at the picture at the bottom that when the driver stopped in the line, then the direction of the traffic is of course changed, and we are able to analyze what is the impact, what is the number of what is the congestion increase in this situation. Okay, these both examples are prepared under our project, and if you need more details, I can share with you our deliverables. We prepared some detailed elements and detailed data about that. Also, at the end, we use these experiments to support Szczecin municipality in preparing of sustainable urban logistics plan. Sustainable urban logistics plans are very important documents, but not often used by municipalities. On the one hand, we have to prepare sustainable urban mobility plans in our cities, but we haven't got any pressure to prepare sustainable urban logistics plans. And sustainable urban logistics plans are very similar to sustainable urban mobility plans, but they are more focused on city logistics, on freight transport. I don't know what about other countries. What about Italy or Romania? Do you have sustainable urban logistic plans in your city? Yeah, that's good. That's good. In Poland, we still have to do that, and we've got some examples in some cities like Gdańsk, for example, and Wrocław started to prepare it, but not now. Okay, that's all from my side. Thank you for attention.